Hello everyone. I'd like to give you some help on this number one problem. And first of all, I will use a notation of a bar for negation. So the expression looks more compact. And okay, you're giving a circuit, looks complicated. I just don't want to redraw it here. And you are able to change this to derive the logic expression from the circuits, and assuming you get this result, okay, x equal this. Don't quote me, I may have made a mistake. Okay, what I want you to do is to have this Boolean expression, but that's not all I want to do. I will also ask you, can you simplify it? But of course, if I ask that way, if you say, oh no, I cannot simplify it, that will logically count as a answer. You get pass, you get credit. But what I really mean is that please simplify this. And after you simplify it, and you get redraw the circuits using simplified logic expression. Now, here's how to simplify it. So realizing this is the knot of the whole thing. So this is boiled down to repeatedly apply the De Morgan's law. So first I apply De Morgan's law. This all become the end. Here are two terms, and end. This part and this part. And then apply again to the details of this C naught and D naught, and A and B and not. Then this or and becomes this or again, like this. And this part, similarly, De Morgan's law, this and become this or again. So this not. And then here you still have multiplication. And then you go one step further. So not, this product become or, again De Morgan's law, C not, D not. So then obviously they become C and D, and this one, De Morgan's law, or become and. So then not, and it's and become or become and. So now each step in your homework, I want you to explain what logic identity is used, not just write down the answer. By the way, what I wrote down may not be correct, okay? So I just show you the way. So then you have C and D, and so now from here, you may think, well, you're done. If you leave it here, I think, well, you simplify. Okay, looks simplified enough. But then the philosophy is what counts as simplified, okay? But you can have different forms. Yeah, and then the rule requires knowledge beyond this Boolean algebra is that a fewer operation as possible, or you prefer those operations that you can make gate, okay, and conveniently make logic gates to make a semiconductor circuits, then that is where actually engineers or manufacturers prefer making certain gates to other gates. So therefore, then it's really absolutely right or wrong, but whichever is preferred. So then you multiply this out, for example. So we change our expression towards that direction. So now you apply this distribution law again. So this 4 term become this 4 term. So this times that, and this, and that, and this, and this, and this, and that. So you have 4 term. So then, of course, you further apply this multiplication, absorption, and these rules, and you end up with here, like this. So this looks simpler, but not only simpler, but it has the form of commonly used gate in the circuit industry. So say, for example, this C and D is simply OR gate. And then see if you ask why I prefer A naught or B naught to this, or prefer this to that, so these are equivalent by De Morgan's law, because this way is a NAND gate, but that way you will need 4 gates, right? So this one is OR, and there are 2 of the NOTs, okay, or diodes, you would say. So then this one is just a single unit of the gate. So that's the knowledge beyond the mathematics. So we need to prefer this one. So that one again, this you will use the identities. I ask you to explain why you get this, and then you have C and D, and that's the end, and then this is A and D, B, A or B and not. So that is typical a OR gate. So you prefer to change this to that. Okay, of course, if you have trouble getting to this, I will not object that much, but just in general, there is no exactly standard way of how to simplify this. Sometimes it can get more and more complicated, but make sure you follow the identity. You don't want to make it wrong. Okay, so this, in other words, this circuit equivalent to this one. So now it has OR gate, NAND gate, AND gate, and OR. So then I want you to draw the circuit based on this simplified form. All down here, I already give you some hint. So this is this is a OR. So you see there are two ORs. So there are three items. So there's a 3 input OR. And then I think you guys are powerful enough, capable enough to make this 3 gates. So complete this part. So if you still have questions or have difficulties, you can leave a message at either discussion board or send me emails. Okay, hope that's helpful. Bye bye for now.